Classical computers use bits, but quantum computers use qubits. What does that mean, and why is it revolutionary? Let's break it down in today's video. Let's start with the basics. Classical computers, like the one you're probably using right now, process information using bits which can either be a 0 or a 1. These bits are the foundation of everything you see on your screen, your games, emails, or even this video. Everything is made up of combinations of 0 south and 1 south. But in the quantum world, things get a little weird. Instead of bits, quantum computers use qubits. These are quantum versions of bits, and they can do something classical bits can't: exist in multiple states at once. Think of a qubit like a coin spinning in the air. While it's spinning, it's both heads and tails at the same time. This is called superposition. When we measure it, the coin lands and becomes either heads or tails. Superposition allows quantum computers to process multiple possibilities at once, making them vastly more powerful for certain tasks. And then, there's entanglement. Imagine you have two qubits that are so deeply connected that changing the state of one instantly changes the state of the other no matter how far apart they are. This mysterious connection is what allows quantum computers to perform calculations that classical computers can't even dream of. So, why does this matter? Well, quantum computing has the potential to revolutionize many fields. Let's look at a few key applications. 1. Artificial intelligence (AI). Quantum computers can process vast amounts of data at once, making them perfect for speeding up machine learning and AI algorithms. This means we could see smarter AI systems that can make decisions faster and more accurately too. Cryptography. Quantum computing is also a game changer for cybersecurity. Right now, most encryption methods are based on the idea that breaking them is impossible for classical computers. But quantum computers could crack these codes in a fraction of the time, forcing us to develop new quantum-resistant encryption methods. 3D simulations. One of the most exciting uses of quantum computing is simulating molecules and complex systems. This could lead to breakthroughs in drug discovery, energy production, and materials science. Think about discovering new medicines or designing more efficient solar panels. Now, it's important to mention that we're still in the early stages of quantum computing. The technology is incredibly complex, and we're just beginning to scratch the surface. Quantum computers need to be kept at extremely low temperatures and are very delicate. But scientists around the world are working hard to overcome these challenges. Do you think quantum computers will replace traditional ones, or is it just a futuristic idea? Let's discuss in the comments below. And don't forget to like, subscribe, and hit the bell for more tech insights. Until next time.